This is the Capstone project for Group 3, presented by Brandon Mondile, Vincent Purcell, Talia Flamini, Mark Norbury, and Stephen Sanderlin. Our project is an analysis of sentiment for posts and comments on various social media platforms. The post sentiments were arranged on an hourly timeline in order to discover how user sentiment varies throughout the day. Our hypothesis is that there will be points during the day which will reflect a more positive or negative mood of the user base as an average. These points of interest during the day could further be used to investigate potential uses in other goals such as marketing or engagement for surveys, etc. Here is an outline for the information that will be covered in this presentation. Methodology of the sentiment analysis, data mined from different API sources, the analysis of the collected data, the results, lessons learned, and the potential stretch goals. The data was collected using Rapid API, Google Client API, Instagram Scraper, and Twitter API. It was then stored in a MySQL database, and TextBlob was the library used for the sentiment analysis. TextBlob has a pre-trained model for sentiment analysis, and considering we did not have training data, we could have either used a pre-trained model, or we could find a training data set online, and we decided to go with the former. Here's a breakdown of the data that was mined. 10,000 tweets, 10.7 thousand Instagram comments, 10.5 thousand YouTube comments, 5.4 thousand Reddit posts, and 21,000 Reddit comments. Here is a visualization of the data breakdown previously mentioned. The next few slides will be the individual social media platforms' breakdown of sentiment. And here's a couple things to keep in mind. Time is in 24-hour GMT. The following graphs show proportions of comments by sentiment, not absolute numbers. Their slice on the graph shows the range, meaning they shouldn't be read as being started from zero. And Twitter data collection did not go as planned, but that was not caught until the visualization stage late in the project. Here's the Reddit comment sentiment proportions, and as we can see, the number of all posts, regardless of sentiment, increases and decreases together, as we would expect, while the total number of all users of the platform waxes and wanes throughout the day. Here's the breakdown for the Reddit posts, and as we can see, there's a plurality of neutral posts. And we can also see that if we ignore the neutral posts, there's a bigger slice of positive posts than negative posts overall.
Here we have the total count of YouTube comment sentiment. The key on the right gives the coloring for the different sentiments. We can notice that the comments are mostly positive or neutral, which may be unexpected by some. We can also notice a huge dip in activity during 700 and 1200. So this being in GMT time, we could subtract 4 hours to get to Eastern Standard Time. So that would make sense that there's dips during those hours. Those would be off hours. And then we can also see a noticeable peak at 1100, which would be 7 a.m. Eastern Standard Time. So if content creators are trying to get more engagement, they would post right at the beginning of the day. And then we can also see a noticeable spike in activity from 2000 to 500, which that would be 4 p.m. to 1 a.m. Eastern Standard Time. So those are core hours when people are home from school, home from work, and that's when we would see most of the engagement. Here we have the Instagram sentiment count by hour, again in GMT, and the sentiment key is on the right, and we can see that overall engagement stays relatively the same for Instagram, except for the noticeable dip between 900 and 1100, which in US time that'd be very early in the morning, so that makes sense. And unlike YouTube, we do see slightly more negative comments, but overall it's still neutral and positive. Here we have the Twitter sentiment count, and as you can see, there were issues with the data collection that we caught too late into the project. Tweets were only collected at 2 different times during the day, which provides us with no meaningful analysis for our goal. But we didn't want to remove the Twitter portion from our project completely, as we can learn from this. It is important to determine the quality of your data before you go to do analysis. So for the next portion of our project, we wanted to go over the positive versus negative breakdowns for each API. The next few slides will have breakdowns of positive versus negative comments for each platform. Notable positive times are denoted by green circles, and notable negative times are denoted by red circles. Periods of frequent oscillation between positive and negative are denoted by orange circles. And we excluded Twitter from this part of as the data was unreliable or incomplete. And we also removed sentiments that were determined to be neutral, as we really wanted to focus on positive versus negative. So here we have the positive and negative breakdown for the Instagram comment sentiment. You can notice the positive peaks in green and the negative peaks in red. And you can also notice that as the day goes on, it gets slightly more negative, which is interesting. So some analysis notes for the Instagram sentiment. There were high peaks and valleys, and the notable positive times were 3 a.m., 9 a.m., 2 p.m., and 4 p.m., and the notable negative times were 12 p.m. and 3 p.m. And again in GMT, so if you want Eastern Standard Time to relate back to your time, you subtract 4 hours. But overall, the comments were mostly positive. So here we have the positive and negative breakdown for the Reddit comment sentiment. We can see from 0 to 400, there's an oscillation denoted by an orange circle, and we see 2 positive peaks, and then we see a negative peak at 1800, followed by 3 to 4 hours of more positive comments. So some analysis notes for the Reddit comment sentiment. There was very low variance, there was short peaks and valleys, with a lot of notable positive times at 6 a.m., 10 a.m., and a huge gap from 8 p.m. to 1 a.m. And there was only one notable negative time at 6 p.m. And there was a period of quick oscillation from 1 a.m. to 4 a.m. Overall, it was very flat and mostly positive.
This slide is the positive and negative Reddit post analysis. The graph below is the percentage distribution of the Reddit post sentiment. The top graph in green shows the positive sentiment, while the bottom graph in red shows the negative sentiment. The x-axis shows the hour of the day, 0 to 23, and then the y-axis shows the percent of total count of sentiment, top being positive, like I said, bottom being negative. So the top graph, as you can see, we had a peak sentiment value of 70% around 4 a.m., which corresponds to a low of negative sentiment at 4 a.m. We had a peak negative sentiment around 6 a.m., which corresponds to a low positive sentiment at 6 a.m. There are other peaks shown above at 11 a.m., 1800, and 2200. Here are some key takeaways and results of our Reddit post sentiment analysis. There was a very high variance with large peaks and valleys between the positive and negative sentiments. Some notable positive times were between 4 a.m. and 5 a.m. Notable negative times were 6 p.m. and 10 p.m. There were periods of quick oscillation from 12 a.m. to 3 a.m. Overall, it was mostly positive, but high variance with mostly jumps and negative posts. This slide is showing the positive and negative YouTube comment analysis. The top graph in green shows the positive sentiment. The bottom graph in red shows the negative sentiment. Along the x-axis, we have the hours of the day from 0 to 2300, and along the y, we have the percent total count of sentiment. The top graph, we see a peak positive sentiment around 8 a.m. and 1400, which is 2 p.m. This corresponds to a peak or a low negative sentiment at the same time. Overall, this graph is relatively smooth with not high variance in the sentiment changing. Here are some key takeaways and results of the YouTube comment sentiment. Overall, there was very low variance, with short peaks and valleys. Some notable positive times were 8 a.m. and 2 p.m. Some notable negative times did not exist because there were no significant spikes in negative comments. Of all the platforms that we've analyzed in this project, this data set surprisingly has the lowest average negativity. Overall, there's a very flat sentiment spike and mostly positive. Here are some lessons learned throughout the project. Our Twitter data was not spread out throughout the day, and we were unable to analyze it correctly. Twitter data also, for some reason, didn't trip negative sentiment, only neutral and positive. When collecting the data from Rapid API, the monthly rate limits from the free trials limited the amount of data that we could collect from the platform and perform analysis. Also, the lack of different APIs found on Rapid API limited what scope of social media platforms we could use when performing these analyses. We also did not factor in time zones for our analysis, and it could be the reason why some of our data shows a lack of noticeable trends. This slide will talk about the potential future of our project and further analysis we could perform. Here are some stretch goals that we could do. We could break down the analysis by day of the week, day of the month, and/or time of the year instead of just hour of the day. We could perform more advanced statistical analysis, including covariance, correlation coefficient, etc. We could break up the data by region and time zone for more specificity. The more narrow, the better. Different regions may have different times of sentiment, positivity, and negativity, etc. We could also train our sentiment analysis algorithm better for more accurate results, which includes a larger, more diverse training set, maybe a different language models or a different Python library that we could use.